Okay, we are going to solve problem number 1, which state that find the following limits without a table of values. If the limit doesn't exist, then justify why not and write doesn't exist. If you are using L'Hopital rule, then justify using it by stating the indeterminate form of the limit. Part A. We have this limit shown as in the paper. If we substitute, we will get infinity over infinity, so we can use Hopital rule. So using L'Hopital rule, will be equal to limit x approach infinity. We will take the derivative of numerator and denominator as the orbital rule stated. So this will give us x over 10, 1 over 10, 3x squared will be equal to limit x approach infinity e x over 10, 30x, and again we get infinity over infinity. So we will go and apply the Hopital rule again. Limit x approach infinity for this one will be e to the x over 10, 1 over 10, and 60x will be equal to e x limit x approach infinity over 10, I said, and 600x. Again we get infinity over infinity, so we will apply it again. Equal to L'Hopital limit x approach infinity. And for this one, e x over 10, 1 over 10 over 600 will be equal e limit x approach infinity e over x over 10 over 6,000, and this will give us infinity over 6,000 will be equal to infinity, and that is our result for this problem. So limit x approach infinity e x to infinity x over 3 will be equal to infinity. Okay. This is for part A. Now we have part B. State that find again the limit x to minus x when x approach again infinity. Again infinity. Okay, this will be equal to, we can factor, making limit x infinity x minus 1, then will be, if we substitute this one, we'll get infinity multiplied by infinity, and that will be equal to infinity. And that is our our result for this question. Now for part C, state limit when x approach 0 to square x square plus 9 all minus 3 over x to the 2. Yes. Here we can rationalize the numerator. So limit x will be equal to 0, x plus 9 minus 3, x plus 9 plus 3 over x squared and x squared plus 9 plus 3 by rationalizing, using rationalizing. Then it will be equal to limit x approach 0. Here we will get x to the power 2 plus 9 minus 9 x2 plus 9 plus 3 and will be equal to limit x approach 0. This one will go this one will go with this one, which will remain here 1 over x plus x to the power 2 plus 9 plus 3, and it will be equal to, sorry, yes, 1 over 0 plus 9 plus 3, and this is equal 1 over 6, and that is our solution for part C. Now let us go to the last part, and last part, part D, which state to find the limit of ln x tangent pi x over 2 when x approach 1 from the right side. Okay. This one, if we substitute 1 when ln approach 1 from the right, means it will approach to minus infinity. For tangent, when approach this tangent, it will approach to 0. This one will approach to 0. 0. So we have to change this one to fit with using Hobbit-Thyle rule. Limit x plus 1, if we put ln x and put that one as cotangent pi x over 2. Okay, then we will get, we will change the tangent to the cotangent, so this will be equal to infinity or infinity, and then we can use Hobbit-Thyle rule, using Hobbit-Thyle rule, which state equal to Thyle rule derivatives of limits, sorry, limit x approach 1 plus 1 over x. Cotangent is the derivative of it is minus cosecant square pi x over 2 multiplied by the derivative of the inside, which is pi over 2. And this will be equal, if we substitute 1, so it will be equal to 1 over 1, which is 1. We don't need to put this one. It's 1 over 1, 1. And here we have pi over 2. This one is, cosecant. This amount will be also 1. It's also 1 over. And so we will get 1 over minus pi over 2. Then we will get minus 2 over pi. And this is our solution for part D. Thank you.